In this video, I'm going to detail what is expected for the Advanced R project. So this project is really a final project for the 2 credit portion of this, and it's designed to take 2 weeks. This is really weeks 8 and 9 of the 2 credit course. And you can find a link to the PDF describing the Advanced R final project right here. So basically, we've spent all this time learning how to utilize R for geospatial purposes, and I think that by now I hope that you feel confident in coding in R yourself. So this final project involves you coding in R to demonstrate proficiency with the language. So you have 2 weeks or 4 in-class time periods to accomplish these tasks. And yeah, so I'll be around still with the same normal online meeting times. And basically this represents 20% of your final grade for the 2 credit portion. Now, for the final project, you have 2 options. The first is you can choose your own. So this is, you choose your own data set, whatever data set you want. It could be a data set that you need for your thesis or for another class. Doesn't matter. What you're going to do is you're going to load the data set in, quality control or quality assure the data, and explain why you're doing what you're doing. Perform some basic statistical analysis, create a function for your analysis or plotting, just show that you can create a function. Use advanced customization with base R plotting. Use ggplot to plot your data set. Add shapefiles or maps if it's a spatial data set, or show trends if a time series. So you don't have to show each and every one of these 9 things, but this is kind of an example of what you could do with your project. Basically, I don't necessarily care what you do so long as you show and demonstrate proficiency in R. We've covered a lot of topics, and there's so many different things you could do. I would love to see some cool things that we've done, either just with ourselves, or if you wanted to go out and try something new, try a new package and show and tell me how that package works, that is fine too. So I'm not picky so long as you show that you are proficient in R and that you're not, don't cut any corners. I mean, you have plenty of in-class time to work on this, so just please take it seriously enough. For the Python project last semester, we definitely had some people who took advantage of the final project, and I mean, this is not asking a whole lot. So use it as you wish. I mean, if this is something that you can use to advance your own thesis, or to advance your own dissertation, or to advance you in another class, do it. This is your chance to double dip. Submit the final images and R script to Canvas before May 13th, 2021 at midnight. So I do need to change that. Really, it should be this. It's 4/18. So ignore this. I'm going to change that before you actually load this data up, and please just load it before April 18th, 2021. Now, option number 2. This is if you don't have a data set that you want to work with, you don't have anything that can really do for your own final project. So you can do something like this if you wanted. So compare DIOS, agricultural weather versus climatology. Basically, we have 2 data sets. We have one data set that it's a map of Delaware and has agricultural weather variables such as temperature, heating degree days, cooling degree days, just some different weather variables that impact Delaware agriculture. We also have a climatology version of that. It has a climatology for each day of year. So in any given year, 365 days in a normal year, 366 in a leap year, and basically for each day of the year, you have an average temperature, you have an average heating degree day, you have an average wind speed, an average pressure, and so you can use that climatology data set as a reference guide. So what I'd like you to do is use the NetCDF4 links above. You'll want to select a single latitude, longitude point within each data set. If you want to go back, you can use the Threads remote data extraction to do this. This is how you will need to do this. So you just want to select a single latitude, longitude within this data set. Again, it's only over Delaware. And you'll want to grab the temperature variable. And specifically that variable is going to be mean temp. So you're going to do the same thing with latitude, longitude of the climatology data set, the same lat log, and grab mean temp for there as well. Now, the mean temp of the climatology data set is going to be the average for the entire year, right? So this is going to be the average for the entire year. So you're going to need to average each day, or so you can use that using an ab line, or you could also just plot the actual time series of climatological mean temp. I don't care which one you do, just so long as you do that. So then you're going to want to select a recent day. After you make that plot, then you're going to want to select a recent day from the agricultural weather data set, plot a raster image of mean temp. So now instead of getting a point data set, you're just grabbing one timestamp. And so you have a gridded data set, plot a raster image of that. Find the same day for climatology. For example, if you selected April 16th, that is 107th day in leap years. So select the 107th day for mean temp variable and climatology data set. Plot this day's average temperature. So you're just plotting the raster of the climatology data set for the same day. Then the last thing you'll do is you'll subtract the mean temp raster climatology from the actual mean temp for that day and just show the difference, show that plot. So again, submit all the resulting images to UD Canvas before 4/18/2021 at midnight.